Okay, I'm gonna share my screen. So first we're gonna list down the topics you find difficult, and then we'll start with what we're gonna do today.
And by the way, my name is spelled VRAJ.
Yeah, I just saw your Zoom thing. I'll just change it. So, rename H- okay. Yes, so you can tell me the topics you find difficult first.
Oh yeah. Wait, let me just get my book.
Sure.
Okay, so the first topic is probability.
Okay. Probability.
Probability thought. Second is like translating, reflecting, and stretching graphs, right?
Okay, so let's say translation of graphs. We'll cover the reflection and others in this. Okay.
There are more. I don't remember right now. Oh yeah, Venn diagrams. Like like how to like shade Venn diagrams and tell them like what does A union B intersection mean, something like that.
All
That
right. Venn
yeah,
diagram. Okay.
yeah, and I think that's it. And can we do like some like questions like hard questions on those three topics and like some other topics like like uh, sine rule, cosine rule, and like area of a triangle and stuff.
Yes. So
And
sine,
like
cosine.
yeah, and actually surds, yeah, that's hard as well.
All right. Okay. So a total of four things you've told me: probability, translation, reflection, and all of those graph things, Venn diagrams, and sine and cosine rule. Area of as well.
Like sine and cosine rule are not hard, but like I just want to practice hard questions of it because I guess because the past papers that I did, right,
Yeah.
most of them have sine and cosine rule as their 5 and 6 markers.
All right. So for sine and cosine, we just need to practice past papers.
Yeah, and like other topics as well, but like I can't remember them right now.
Sure, sure. That we can. So
Oh, sequences, yeah,
let's start with probability,
yeah.
and then we can move on to graphs, and then we can move to Venn diagrams, and then we can move to
Oh,
past papers.
there's surds as well.
Sorry,
There are surds.
I cannot hear you properly.
Hello.
Hello. Yes, yes, I can now. I can hear you now.
Oh, surds.
Search.
Yeah,
How do you?
like wait, I'll show you 348. You have like you have to simplify them, right? The surds and stuff. Like you have a root and something, and then
Can you spell it out for me?
surds.
SURDS. Okay, so I'm not sure of this word. I'm gonna look it up and then I'm gonna tell you.
Okay.
Okay. Maybe it's some. So we've added search to this as well. So this I'll look up and I'll let you know, and we'll of course cover it. So, if this is all, then we can start with today's class, and we can discuss probability first.
Yeah.
Is there something that you want to ask or any questions before we move on?
No.
Okay. So we're going to talk about probability. Okay. So we're gonna first cover some vocabulary that is used in probability. So the first one is a sample space. Do you know what a sample space is?
Oh no,
Or can you tell me?
I don't know.
Okay, you don't know. All right. So probability or sample or probability is basically um the judging of a result of an experiment, right? So whenever we perform an experiment and we see that maybe if we are tossing a coin, we say that what is the chance of getting a heads on it? So that chance, that calculation of that chance is called the probability. Sample space basically is when you perform an experiment, the set of all possible outcomes, anything that could come is your sample space. So basically, it just means when you perform an experiment, the set of all possible outcomes is called sample space. So, by an example, I think it will be easier. So, if a coin is tossed, what are the possible outcomes that could come? What do you think?
Two heads
Exactly.
and tails.
So, we denote sample space by S, and we say that if a coin is tossed, if a coin is tossed, sample space would be equals to head or tails. Okay. So
Okay.
we just list down all the outcomes. If we roll a dice, what possible outcomes do you think that will have?
1 to 6.
1 to 6, exactly. 1, 2, 3, 4, 5, 6. If I toss two coins, if two coins are tossed at the same time, so what do you think is the sample space?
Heads and tails, tails.
Heads, heads, tails, tails. But
Heads, tails,
yes,
tails,
and
heads.
tails, heads. Perfect. So these are the possible outcomes that could come. So this is basically a sample space. Now, there could be questions that ask you what is NS. NS simply means the number of outcomes in a sample space. So for the third one, there are four, right? 1, 2, 3, 4. For the second one, there are 6. For the first one, there are 2. So there could be questions that ask you this as well. So is the concept of sample space clear to you?
Yeah.
Okay. So what if there is a pair of dice rolled? How many outcomes do you think there will be?
A lot. Cause 1, 1, 1, 2, right?
Yes. So it's gonna start with 1, 1, 1, 2,
1, 3, 1, 4, 1, 5, 1, 6, 7, 8, 9, 10, 11, 12.
1, 6.
Oh yeah, 1, 6. Yeah.
Yeah, that would be the highest sort of the number 6 would be the highest. Then we would have 6, 6, right? And then it would go down for each number like this.
Yeah.
So in this case, since both of the outcomes both of the dice have the same number of outcomes, both have 6 outcomes. So when you're trying to find the size of sample space, you would do 6 into 6 and you'll get 36. So there will be 36 outcomes in total.
Oh, so wait, why'd you do 6 times 6?
Because each dice has 6 outcomes.
Oh, so you just do total number of outcomes of both and just multiply it.
Exactly. So if it
Okay.
were a dice and a coin, it would have been
12.
2 into 6. Yes, 12. So you need to see the outcome for each thing, and then you just multiply it to get the number of total outcomes in a sample space. Okay.
Okay.
Okay. Now next we have something called an event. So event is essentially a statement that is associated a statement that is associated with a random experiment. Random experiment. So that one or more, maybe none, of the outcome is true. This this just simply means an event is something that describes or that gives you a particular situation, which means that, let's say that 2 dice are rolled, okay, and in totality they give you a statement that the sum of both the numbers that appear on each die should be equal to 9. So that is an event. This statement is an event that they're asking you to tell whether the numbers that show up on each dice, um summing them gives you 9 or not. So this is basically an event. It could be different as well. So for the first one, like I said, that the event is sum of the numbers on 2 die is 9. So in what sample space do you think this will be true? What numbers?
4 and 5, 5 and 4,
Yes, 4 and 5, 5 and 4.
3 and 6, 6 and 3.
Yes, 3 and 6 and 6 and 3. So that's exactly how you're going to solve you're going to tell a sample space for when an event is defined. Now all of the other numbers that appear on the dice, we don't have any concern with them because they don't sum up to give us a 9. So sample space is like a very general thing. Anything sort of could come in a sample space, but when it's an event, it's more specific and it's more particular to one thing only. Does it make sense to you?
Yeah.
Okay, perfect. So another example could be that same number appear on both dice. So what do you think is the size of the sample space in this?
6
Yes,
was
and
1, 1, 2, 2, 3, 3, 5.
exactly 1, 1, 2, 2 up to 6, 6. Okay. What if the event is that getting exactly one head on two coins, on actually three coins? Yes. So what do you think is the sample space for this?
Heads, tails, tails.
Heads, tails, tails. Yes.
Tails, heads, tails. Heads, tails, tails, head.
Tails, tails. Yes. So that's perfect. And let's just do one more, which is getting at least one, getting at least one tail on two dice, on two coins.
Tails, heads, and heads, tails.
Tails, heads, and heads, tails. There's one more.
Oh, okay, tails, tails as well.
Yes, because it says at
At
least
least.
one tail. So there could be two as well. Okay. Now, another vocabulary word that you should know is equally likely. This means that the chances of any outcome uh, coming or resulting are the same. So if there's a 50% chance of getting a heads on a coin, then there has to be 50% chance of getting a tails on a coin. So the chances should be equal. So the examples of this could include a fair dice. A fair dice means that it has numbers from 1 to 6. There are questions that may appear that the dice has numbers from 1 to 5 and it repeats 5 two times. So that's not a fair dice because it has 5 two times. So the chances of getting a 5 are greater than the chances of getting a 4. Right?
Yeah.
Okay. Then we have an unbiased coin. By unbiased coin, they mean that both sides, one side is head and the other side is tail, and the coin is flat. Because at times they so for their own like getting the favorable outcome that they want, they try to what do we call it, they try to change the coin, they try to make it more towards the side that they want to come. So a flat coin is an unbiased coin. And then there's a concept called with replacement. So with replacement means that if there is a bag of 10 balls and you take out and 5 balls are red and 5 balls are green. So you take out one ball and that is red. So now in the bag you are left with 4 red balls and 5 green balls. Now this is not equally likely, right? Because the number of green balls is greater than the number of red balls. With replacement means that if I'm taking out a red ball, I'm going to put one red ball back in as well. so that the chances are always equally likely of getting a green ball and a red ball. Does that make sense?
Yeah.
Okay. All right, now we can move on to probability. So probability is that if if a random experiment is performed, such that its sample space has n equally likely outcomes. And m are favorable to an event associated. Then probability of happening event E is denoted by one probability of E. Okay, now let's walk through this definition. So let's understand the first part. It says that if a random experiment is performed such that its sample space has n equally likely outcomes, it means that there's any random experiment. Let's say there's a bag, let's just continue with that example. There's a bag of balls with 5 red balls and 5 green balls. So the sample space has n means 10 because we have 10 balls. Equally likely outcomes. Equally likely means that we have 5 red and 5 green. So the chances of getting a red ball are equal to the chances of getting a green ball on a random draw, right? So the first part says this, that if there is any random experiment and the sample space has n number of outcomes that are equally likely, that has the equal chance of coming. So this is what the first part says. The second part says that M are favorable to an event E associated. Okay, so M are favorable to an event E. It means that out of those N outcomes, M, which is less than N, M is less than N, favor to a particular event. Maybe um, the event, as we described earlier, event is something that is a statement that gives you a scenario, that gives you a situation. So are you saying something?
No.
Okay, so so M outcomes out of those N are favorable to that particular event. So if that is the case, then we say that there is a chance that we can calculate its probability. Do you understand the definition of probability?
Yeah.
Okay. So now the formula that we use for calculating the probability of any event is number of favorable outcomes divided by total number of outcomes. Okay. Now, if we continue with our examples that we did in the beginning for an event, let's say sum of the numbers on two dice is 9. So sum of the numbers on two dice is 9. Now, the sample space for an event is what is the number of outcomes in the sample space for the event? Are you there?
Yeah.
Yes. So can you tell me what is the sample space for this event? The number of the sample space.
Okay. Number of sample space. Okay.
Yeah. What did you say?
Uh, so I think 4 and 5 is 1. 5 and 4.
Yeah.
Are there more? 3, 6, 6 and 3, 3 and 6.
Yes. So the total number is 4, right?
Yeah, 4. Yeah.
Okay, I'm gonna put this. You don't use these brackets when we are turning the number. We have 4. And what is the size of the entire sample when there are two, size of the outcomes for when two dice are rolled?
36.
36. So this is our favorable outcomes. Favorable. And this is our total outcomes. Right?
Yeah.
So now we use this formula, P probability of the event, and we do 4 divided by 36. What is the answer that we get? 1 divided by 9. 0.11. So the probability, so we say the probability of getting the sum of two dice rolled as 9 is 0.11. Okay.
Yeah.
All right. So there are two things that you need to know. Probability can never be greater than 1 and can never be less than 0. So probability is between 0 and 1, both 0 and 1 inclusive. So probability can be 0 and probability can be 1. Now probability, when probability of any event is equals to 0, that is an extreme case of when it is an impossible event. That this cannot happen, impossible event. and probability of an event is equals to 1, which is also an extreme case, is that it is like a for sure event. Otherwise, whenever you calculate the probability, it would be between 0 and 1, unless we have these two extreme case scenarios.
Okay.
Okay. Does this make sense to you? Any question till now?
No.
Okay. So I'm gonna give you a question, just like the ones that we did right now. So find the probability for part B and part C, and then tell me what you get.
So for the first one, right?
Yeah.
So there are 6 outcomes, right? And that total 36. So 1 over 6.
Yeah, 1/6. That's perfect. And what about this one?
So 2 coins are tossed, right? So 2 2s are 4, 4 3 over 4.
Okay.
Yeah.
So
Oh,
uh,
that's the 3 coins. My bad. Oh, yeah. So if there are 3 coins, 3 6 3 or 6 half.
3/6. Exactly. And this is going to be 2 1/2. Yes. So this is how it is going to be. All right. Now let's move on. Okay. So now we're gonna talk about another concept that is used in probability, which is called the expectation. So it is basically if the given the probability of the event E, which let's say is equals to P, and the number of times n the experiment is repeated. Such as the probability remains in each trial, then the expectation so expectations definition says that given the probability of the event E is equals to P. Okay, so the probability of any event happening is given to you, which is equivalent to P. P could be any value between 0 and 1. And the number of times the experiment is repeated. So the number of times the experiment repeated just means that you roll a dice once, then you do it twice, then you do it thrice, and then you keep doing it n numbers of times. But your probability remains the same on each trial because we know that it is an unbiased dice, which means that the probability of getting a 1 on the die is same on the first trial, on the first time you're doing the experiment, and on the seventh time you're doing the experiment, the probability of getting a 1 is same. So if that is the case, then we say that the expectation of that event is going to be equals to n into p. N is the number of experiments, it's the number of times the experiment is repeated, and p is the probability of that event. Is this making sense?
Yeah.
Okay. Perfect. So we're going to do an example now. Example. So we have S T A C E S. We say one of the 6 letters is taken at random. Part A says write down the probability the letter is S. Okay, I think we can do this. Can you tell me what's the
1
process?
out of 3.
Yes. So the probability is going to be 1 by 3. Part B says that the letter is replaced and again a letter is taken at random. This is repeated 600 times. How many times would you expect the letter to be S?
Okay, so if the letter is replaced, okay. So
Yes.
does that mean it is like put on back now?
Yeah. So if S is taken
Okay.
out, S is put back in. If S is taken out, S is put back in. How many times
200.
would you? Yes, that's correct. Would you expect letter S? So it's gonna be 600 into
That's
1, 3, which is going to be 200, which is correct. Okay, so that's great. All right, let's do another example. Example number 2. Okay, so the diagram shows a fair Just imagine that this is fair, okay?
Okay.
I'll make it properly when I send you the notes later on. Anna spent it toys and add the scores. A part is that complete the table for total scores. These questions are taken from your past papers.
Okay.
Okay. Then part B says write down the most likely score. Likely score number C. Part C says find the probability that Anna scores number one a total less than 6, number two a total of 3. Okay, so I'm gonna make the table here and then we're gonna fill it. Okay, so score on first spin, score on second spin, 1 2 3 4 5 6, 1 2 3 4. Oops, I think there's no 5 in the 6, so 1 2 3 4 and 6. There's no 2 there as well. There's just 2 times 3. 3 and 3. Okay. So can you tell me the values for the first line, horizontal line?
So do I add them?
Yeah.
So 2, 4, 4, 5, 7,
Second,
4, 6, 6, 7, 9,
third,
4, 6, 6, 7, 9,
fourth,
5, 7, 7, 8, 10,
and the last one.
7, 9, 9, 10, 12.
Okay. So part 1 we have done already. So this part is done. Okay.
Yeah.
Now we have to tell what is the most likely score.
Most likely score, yeah.
Yeah. What do you think?
So most likely score might be like the one with the most probability on it.
Yes. So you just count which number appears the most,
Yeah.
and that is
Appears
the
on.
likely score. Can you tell me what it is in this?
Uh, 7, I think.
Yes. 7 because it is repeating 1, 2, 3, 4, 5, 6 times.
Yeah.
Perfect. Okay. Now we have to see part C. So part C says find the probability that Anna scores a total of less than 6. Yes. So you tell me what's the probability is gonna be.
Oh, probability. So
First
the
define
so the total is 12, right? Like the output is like maximum is 12, right?
maximum output.
No, 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 no. Like 12 is the largest number, right?
Yeah. 12 is the largest number. So you have to tell less than 6. So so
So,
it's easier that you
so the
define
number
space first.
two. So there are 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 numbers out of how many? 36.
25.
There are 25 numbers.
Yeah, see, five outcomes
Oh
for
yeah,
6.
5 of 5 to 5. Oh yeah, 25, 25. Yeah. So
Yeah,
8 out
so
of 25. That's the probability.
yes. So 8 by 25. 1, 2, 3, 4, 5, 6, 7. How did you count 8?
Because there are 8. Because 1, 2, 3, 4, 5. No, wait. 1, 2, 3, 4, 5, 6, 7, 7.
Yeah, there's 7. Yes, so this is the probability. And what about 3?
0.
0, exactly. So see, there this one, the second where there is a 0 probability, it means that this is an impossible event. This
Yeah.
can
Yeah.
okay. So this is the last thing we're gonna do today, and we're gonna end it for today. We'll then hopefully have a class tomorrow. So the last
What time?
so tomorrow we have a class at 7, I think.
7.
Yeah.
Huh? Wait.
Okay, let me check. Yeah, Friday
Oh,
7 and
oh
Saturday
yeah, Friday, Saturday, 7. Wait, is it okay if we do it at 1 on Friday?
at 1. No, I have my job at that time. So for tomorrow, I can confirm in the morning if I can do 1 because I might do work from home if I do that. So I can do just tomorrow's class at 1, but like on other Fridays, we'll have to do it at 7.
Okay.
Okay. If that time is not okay with you, I can give like some other times for other days. If that's
Well, what other times are there?
sorry.
What other times are there?
Yeah, that I can text you once this class is over in the group, and then you can select from that because I'll have to see my schedule.
Okay.
Okay. So the last thing that I want to end this class on is that probability of an event plus probability of not that event is always going to equals to 1.
Yeah.
This means that if the probability of um getting a 1 on, or maybe getting a 2 on a spinning or on throwing 2 die or rolling 2 dice is E, then adding it to probability of not getting a 2 on rolling 2 dice is always going to equal to 1. Does that make sense to you?
Yeah.
Okay. So we're gonna practice its questions in the next class. Hopefully we'll start from here and we'll continue down the line. Okay.
Okay.
So, any questions from what we have done today? Do you
No.
understand it? Any remarks? Anything that I should change in my teaching or something like that? Anything you want to say?
No.
Okay. All right. So, we're going to end it here and I'll see you hopefully tomorrow.
Okay. Bye.
Bye. Take care.